As you lift your arm up to reach for a door handle, there is a lot going on behind the scenes that you may not be aware of. Yes, your shoulder muscles are being activated in order to lift your arm, but there is other muscle activity occurring in different parts of your body, such as your leg or your trunk, even before your shoulder muscles become activated. The purpose of this other muscle activity is to counteract the effects of voluntarily lifting your arm, to prevent you from falling over, and these are known as anticipatory postural adjustments, or APAs. It is still unclear exactly how APAs are controlled. Are APAs always the same? Are they a part of a motor program? Or can they change from one task to the next? The current research set out to answer these questions. First, we will briefly go over some background information. There are two main viewpoints that consider how APAs are controlled. The first theory is that APAs are a component of the motor program controlling the arm raise. What this implies is that every time you voluntarily lift your arm, you will have a corresponding APA. In other words, muscle recruitment order is invariant, meaning the leg muscle activity always precedes the arm raise. The other theory is that of independent and parallel processing. This implies that postural muscle activity can be influenced by a variety of factors, such as sensory input, and is free to vary accordingly. This means that if you are raising your arm in a less demanding position or environment, then postural muscle activity can change. The purpose of the current study was to provide more evidence to settle this debate. Arm raises were performed in 3 different sensory conditions. The results of this study indicate that when a person raises their arm in altered sensory conditions, such as without the sensation of gravity acting against them, the muscle recruitment order is actually reversed. We don't see the APA in the leg during microgravity and lying down supine arm raises, like we do when we're standing upright. If we think back to the aforementioned theories, this provides evidence for independent and parallel processing. Our postural set, which is determined by how much demand is placed on the body at a given moment, influences muscle recruitment order. This means that in a less biomechanically demanding environment, such as microgravity, unique muscle activation patterns can be achieved to perform the specific demands of the movement. In microgravity, you do not need to counteract the momentum of your arm raising, since a shift in your body's center of mass will not knock you over. This provides support for the theory stating that muscle recruitment order can be catered to the specific situation.